Complex fractions. When you come up with complex fractions, just simply reminding yourself of this, that a fraction is a division sign, really, and also know that a fraction line or bar or whatever you want to call it is a grouping symbol. Those two things right there will help you immensely in your world of mathematics. For those of you who are going to be math professors, which there may be one or two in here. So here I will go from the easiest to the hardest. For example, this always seems like it throws people off if they see a problem that looks like this. 1/5 over 2/3. They see a fraction and all of a sudden they're ready to jump off the Golden Gate Bridge. It is not that difficult. If you remember that this is a division problem, you can rewrite it like this. 1/5 divided by 2/3. And dividing by fractions are not very difficult because you simply have to just flip and multiply. This becomes 1/5 times 3/2. And you end up with 3/10 as your answer. Not so bad. Now, a little more complex, this problem here. What if I asked you to change 14 2/7% to a fraction? How does that come into play with what we were talking about? Anybody know how would you do that? Anybody? I asked you to change that to a fraction. You can change to a decimal, I guess, but that still doesn't really get you too far. You got fractions, all sorts of goofy things there. Mr. Fitcher?
Times 14 times 7 plus 2.
Yep. Which gives you,
A number.
huh?
A number.
Well, 98 plus 2, you get, oops, sorry. You get, it's coming back. If you do what Elijah said, I concur. He said, change it to a mixed number is really what he was saying. You actually get 100 over 7%, but that's still in percent form. What fraction is that? Still doesn't give you the fraction. Do you know what fraction it is, by the way, Elijah? You don't. Okay. So that's where this complex fraction thing comes in handy, because what does percent mean? Out of 100. So if you take this and you go, okay, 14 2/7 out of 100, because that's how we change any other number to a percent. If you had 7% as a fraction, it is 7 over 100. That's the fraction. Well, this is it, except you got to be able to know how to do complex fractions. What do you have to do to solve this part of it? Well, we do what Elijah said first. Change this to an improper fraction, which is 100 over 7. Make this a fraction, which is 100 over 1. And it looks just like what we did right here. You just take your 100 over 7, divide it by 100 over 1. If you flip and multiply, you get 100 over 7 times 1 over 100. And look at the beauty of that is what happens? The hundreds cross off, and what fraction are you left with? 1/7. 1/7. Isn't that handy dandy? Don't you just want to write home and tell your parents about that? Did you say go home? Oh, wow. Well, I didn't make the phrase up, I just said. You want me to give you another one? You wanna try it? Here, 4 1/6%. You figure out what 4 1/6% is as a fraction. 4 1/6%. Maybe I'll just do it right here. 4 1/6%. And you can kind of speed the process along. I kind of walk you through in baby steps because it's sometimes easier. 4 1/6 as a fraction. And then we get to the fun part that I really like. 4 1/6%, which would probably be about Elijah's free throw shooting percentage.
I'm 100 right now.
Are you? What are you, Jade?
Me? 75. I've only been there 4 times.
Luke, you been to the line?
No.
Keith, been to the line?
50.
Shot twice or 4 times? Twice. What do we get for a fraction there? Laney, Kovarik? What? Let's see if it works. So you did 4 1/6 over 100. Changing both in proper 25 over 6 over 100 over 1. And I know some of you will skip steps. I try not to because I'll bet some of you flipped it over right away and just did away with this, but I'm gonna write it down because I like to get the problem right. And it becomes 25 over 6 times 1 over 100. Right? Boom, this goes into that once, that goes into that 4 times 1 over 24. 124. Yes? Okay, here we go. Now, the most complex of all. Write this one down. 1/2 plus 1/3 all over 1/3 plus 1/4. Tell me that don't look complex. No, tell me. Who knows what I'm gonna tell them to do first on this? This goes back to this right here. Where is it? Fraction bars are grouping symbols. What am I gonna tell you need to do first here before anything? This fraction bar is a grouping symbol, which means you need to do this addition first, get it down to 1 fraction, do this second one, get it to a fraction, and it's just like the stuff we've been doing. So you need to keep yourself a little organized. If you do 1/2 plus 1/3, thank you for that, you get 3/6 plus 2/6, which on top ends up being 5/6. If I take 1/3 plus 1/4, I'm a denominator of 12, looks like I get 7/12. Now I've got it down to 1 single fraction on top, 1 single fraction on the bottom, and then it's just like the last 2 problems. 5/6 divided by 7/12, which is 5/6 times 12/7. Looks like you get 10/7 there. That make sense to you? You want me to go back, do that in super slow motion? I can rewind, because I can do this. And then I can go back. So here, let me give you one. We'll see how we do here. 1/2 minus 1/3 over 1/2 plus 1/4. Let us see if we can get the majority of folks in this class to get the right answer for that problem. It's a sweet problem. file for Sean. Guessing Riley's done? You done, or you just not doing? You boycotting this class? Some sort of strike or sit-in, if you will? Quite possible. Alright. Now is the time. Kate, what'd you get?
836.
8 over 36, I believe, is not reduced. You'd have to reduce that. What's that? 4/16. 1/4? Wait, 8? No. 836 is what? 4/18. That's 2 ninths. 2 ninths? 4/18 is not reduced either. Oh, yes. Did we get 2 ninths? Everybody get 2 ninths?
Nice.
Let's look. As quickly as I can. 1/2 minus 1/3, 6, 6, 3, 2. You get 1/6 on top. 1/2 plus 1/4, 4, 2, 1/4, 3/4. Yeah. 1/6 divided by 3/4, which is 1/6 times 4/3. 2, 3, 2 ninths. Kate, how'd you get such big numbers in your fractions?
Because 1/6 times 8 over 6 is 8.
How did this, oh, you made your common denominator 8 here instead of 4?
I made, yeah.
That would be, I mean, you can do it that way, just. Enough of that.